Hi, in this lecture, I will compare the sorting performance that we have studied so far. Well, which of the three sorting algorithms is the best of the three? And which of the three sorting algorithms is the worst of the three? Let's find out. Bubble sort, selection sort, and insertion sort are easy to understand and write. You saw the function, and the bubble sort is only 4 lines of code. Insertion sort like only 5-6 lines of code. They are very simple to write, but they are not that efficient. All of them are quadratic sorting algorithm. They work well with small number of items in the list, but they are not suitable for large number of items. There are many other sorting algorithms have been developed. We did not talk about those in depth. Shells, I just want to talk about maybe the overview. Shell sort, sometimes called the diminishing increment sort, it improves on the insertion sort by breaking the original list into a number of smaller sublists, each of which is sorted using insertion sort. One thing you should see is sorting is pretty fast with a smaller list. So if I can break things down into smaller lists, sort them, and then those sorted sublists, we can combine them. It's pretty easy to combine them. A merge sort using divide and conquer. Um, I showed earlier the merge sort using recursive algorithm that we using divide and conquer recursive algorithm to split the list in half, and until we have the sorted list, which is single item, and then we merge them back. Quicksort uses divide and conquer to gain the same advantage as the merge sort, while it did not use additional storage. What that really means is merge sort use recursion, and recursion will use more memory because of the stack. Every time you call the function, you create a stack for the function. Quicksort, it doesn't have using recursion, so it did not have that memory trade-off. As a trade-off, if possible, the list may not be divided in half, so you could see some trouble with the quicksort depending how you partition. But modern day quicksort is really fast. Here's a quick comparison. Bubble sort, best case O(n) if the list is sorted. Worst case n square, selection n square. Insertion, best case is O(n) when there's no change. Worst case n square. Shell would be somewhere between O(n) to n square, linear to quadratic, depending on the data. Merge is a n log n. It requires additional space for merging process. Quick is a n log n, but the worst case could be n square and does not require additional space. Now you might be wondering, what do I use for the list.sort method? It uses what we in Python call timsort. It derived from merge and insertion sort. You can look it up. This was actually developed for Python about 20 years ago. So, of the following sorting algorithm, which one is the fastest? Can you put the relative performance in order? Well, you might not, but what I did is I took all of the function, bubble sort, selection sort using the Python way, and the insertion sort. I add a time and random module. I write using list comprehension, create a list with a random number, given a number random number. If you recall, we did some example like this many weeks ago. I have a time sorting function, which given a list and the algorithm, sorting algorithm, this is what we call a callback function. I start the timer, call the function, then stop the timer, and return the difference in time. And then I have a loop here. I will create a list and make a copy to B and C list from the A list. So A, B, and C list, they all are the same list. I will call bubble sort, selection sort, and insertion sort, and see their performance. So let's see what happened. And I will run the performance with 1000, 2000, 4000, and 8000 elements in the list. And there you can see some intriguing number here. Take a look. Between 1000 and 2000, the time between the bubble sort time, selection sort time, and insertion sort time. And between 2 and 4000, take a look at the time difference. And it's still crunching number here. If you look at the time here, for bubble sort, do you remember all of them are n squared? What that really means is, if I double the number of items, I will quadruple the amount of time it takes to complete the sorting. What? Well, if you take a look at bubble sort, 1000 elements, to sort 1000 elements, it took about 0.21 seconds. And I said that if I double the number of elements from 1000 to 2000, you quadruple the time. From 0.21 to 0.84, it's about quadruple, right? 4 times more. Look at the selection, 0.087 to 0.35, it's about 4 times more. What about insertion, 0.105 to 0.45? Yeah, it's about 4 times more also. Look at from 2000 to 4000, 0.84 to 0.34, that's about 4 times. 0.35 to 1.4, that's 4 times. 0.45 to 1.8, that's 4 times. 4000 to 8000, 0.34 to 13.4, 4 times more. So if I look at this here, when we say about n squared, what does really n squared mean? Well, if it take, say, if it take 1 second to sort 1000 elements, how long would it take to sort, say, 5000 elements? Well, I said it before. What is the difference between 1000 to 5000? What is the I don't mean differences in like factor. What is a factor here? This is a factor of 5. So that basically you would do 5 squared times, in this case, 1. Your baseline is a 1 second. So for 5000, it would take you 25 seconds to complete. And that's why for the quadratic, the n squared will get bigger and bigger and very, very quickly once the number get bigger. And as you can see here, bubble sort is the worst of the worst. Bubble sort is it's like a 2 times slower than the insertion sort. And in this case, selection sort is a little bit faster than the insertion sort. This is Python way. If you implement in different language, you might see different results, but you should see bubble sorts always come up at the rear. They're always the worst one. Insertion sort in some other language, I did it in other language before. Insertion sort seems to be run a little bit faster than selection sort. But for our implementation here, the selection sort actually run faster. Now, you might be asking me, hey professor, what about the merge sort? You say merge sort is the n log n, how fast is that? So I'm going to compare merge sort to bubble sort to selection sort, all 4 of them. And just take a look at here. 1000 element, take a look at merge sort. 0.007 second. 2000, 0.002. 4000, 0.033. I even haven't taken more than a 0.1 second yet, compared to all of them. And finally, the last one will take a long time here because of the bubble sort. But you can see the merge sort is an order of magnitude faster than any one of those n squared sorting algorithm. Take a look, 8000, 0.08 second. That's almost like 100 times faster than insertion sort. Almost, close to 200 times faster than the buffer sort. As you can see, the merge sort really perform very well.